In this segment, we're going to continue talking about fractions, and we're going to continue to talk about comparing fractions. Last segment, we talked about comparing fractions when either the numerator or the denominator was the same, and it was easy to talk about if the numerator was the same, we have the same number, but of different size pieces. And if the denominator was the same, we have different numbers of the same size pieces. We also talked about comparing using a referent, such as 0, a half, and 1, and students were able to relatively easily place them on zeros to ones with practice, and we could compare them that way. But what would happen if our numbers in our referent list were both smaller than a half, or if they were both greater than a half? Sometimes it's too hard to tell just by using that technique, and so we need another technique. And the technique we're going to talk about today is talking about equivalent fractions. And using equivalent fractions is important for comparing fractions. It's also vitally important for understanding adding and subtracting fractions. So I'm going to talk about making equivalent fractions in order to compare fractions today, and I'm going to try to do with a variety of manipulatives, with fraction strips, and with pattern blocks, and a couple of different ways of thinking about our fractions. So here's the hole that I'm going to be using. This is my fraction strip. It goes from here all the way to here, and I want to note that it's never going to change its length. I'm still talking about the same size hole every time. So I have one strip, so I could write it as a 1. But I could also write it as I have one strip and I have it cut into one piece, or one equal size piece. So I could also write it this way, 1 over 1. One piece cut into one piece and one equal size piece, and therefore my fraction could be 1 over 1. Now if I want to take this one strip and I want to keep the same length, but I want to cut it into smaller pieces, I want to subdivide it up. If I have smaller pieces, I'm going to have more of them. That makes sense. And if I have more of them, they have to be smaller. So let's say I want to take this strip and I want to cut it into 2 pieces. I now have 2 pieces, but each piece is smaller than what my original piece was. And that makes sense. If I have more pieces, they need to be smaller. And if they're smaller, I need more of them. What are we going to call each of these pieces? I still have one whole. I've cut it into 2 pieces, so I could call this piece a 1/2 piece, and I could call this piece a 1/2 piece. So altogether, I have 2 halves. And I could write it this way, 2 halves. Now, my strip is still one whole, so 2 halves must be the same thing as 1 whole. So I've made my first equivalent fraction here, and I want to point out a way that we can symbolically talk about how we did that. If I had my 1, and I had one piece, and now I've made it into 2 pieces, I took that top number, which is the number of pieces, and doubled it. But then we said if we have to double the number of pieces, the pieces have to be half the size. So in actuality, what we did then is we actually multiplied it by this 2 over 2 fraction in order to get this new fraction, or this, it's not really a new fraction, it's just renamed. Instead of calling it 1 over 1, we've now called it 2 over 2. The strip hasn't changed at all. I haven't changed the size. I've just renamed it from 1 over 1 to 2 over 2 by multiplying it by how many more do I have, and how does the size have to change? So this 2 over 2 number is what I call the magic 1. And it's important for students to understand that 2 over 2 is just another name for 1. We've just shown that. Here it is right here. 2 over 2 is another name for 1. So if I multiply a fraction by 1, it doesn't change anything. My length of my strip is still exactly the same length. I've just doubled the number of pieces, so I had to change the size of my piece. Let's continue on with, if I want to change the number of pieces I have here, and I would say I'm going to double it again, what am I going to get? So now I'm going to get same size piece, but now I have 4 pieces. I've got one strip cut into 4 pieces, so I can write it as follows. So each piece is going to be called 1/4, and I can go ahead and label those pieces. So all my pieces, each piece is called 1/4, Altogether I have 4/4, and 4/4 is another way of saying 1 whole. And if I take my magic 1, I'm just going to take these here and multiply it by my magic 1. So if I had 2/2 and I multiply it by my magic 1, because I'm taking twice as many spots, so they need to be twice as small, and I multiply these times this, I'm going to get 4/4. So I can start to see that I have equivalent fractions coming up here. I've renamed them. I've got 3 different strips. They're all the same length, but one's called a 1 or a 1/1, one's called a 2/2, the other one's called a 4/4. They may be called different things, but they have the same meaning. And that's what an equivalent fraction is. They have different names or different numbers, but they have exactly the same value or the exact same length. Continuing, if I want to double it again, I need twice as many pieces, so therefore they have to be half as small again. So I'm going to do the same thing again. And so I take my 4/4, I double the number of them, so now I have 8 of them, and therefore the size has to get smaller. So we write that as 8ths, and so 8/8 is what I get. 4 times 2 is 8, and 4 times 2 is 8. So 8/8 is another name for saying that strip. So 8/8 is a whole strip, 4/4 is a whole strip, 2/2 is a whole strip, 1/1 is a whole strip, and so they're all equivalent. And all I'm doing is changing it from one to the other by multiplying it by this form of 1 known as 2/2. And one last time, if we double it so that we have even more pieces, the pieces have to get smaller, and so that would be what size? And so I'm doubling the number of pieces I have, so 8 times 2 now gives me 16 pieces, and so the size is going to have to get smaller. It's going to be half as small, and therefore it needs to be 8 times 2, which is going to give me 16, so 16/16 is another name. It's an equivalent fraction for 1 whole. So we're trying to get the idea that multiplying by some kind of magic 1 will produce an equivalent fraction. If you're using your hexagon as 1, we start off with 1 whole hexagon, and I want to rename it into smaller groups. So if I double the number of groups, they have to be half as small. And there's my 2 2s, or my 2 halves, to make 1 whole, just as we did before. Now if I want to cut them in half again, this is somewhat of a problem using the hexagon, so this is where we use the new fraction blocks that allow us to make things into quarters. And there lies some of the problem with working with the pattern blocks. I should have started off with this as my 1. If this is going to be what my 1 is, and I want to divide it into 2 pieces, there is my 2 pieces. So I've got now my 2 2s. So if the pink is 1 1, this is 2 2s. If I want to double it again to make it into more but smaller pieces, I have to have 4 4s. And there's my 4/4. So there's my 1 1s. Here's my 1 2 2s. Here's my 1 2 3 4/4. And due to the nature of the pattern block, getting 8ths is very difficult, and so we're just going to stop there. Now some students might see a pattern here and they're saying, okay, well, that's great as long as I'm dividing by 2 or changing by 2s, but I can do the same thing. If I want to divide it into more pieces, I could change it into 3 pieces, in which case my pieces would have to be 3 times smaller, or 1/3 the size. So just as showing I did before, making things twice as small, they have to be twice as many, have to be twice as small. If I want 3 times as many, they need to be 3 times smaller. So now my magic 1, instead of being 2/2, is now going to be 3/3, and I'm going to get a whole, same length, except now it's written in thirds. So 3/3 is another equivalent name for 1/1, or 1 whole. Combining the two ideas, what happens if I want to take this one and say twice as many spots now? I need twice as many, so they need to be half as big. So it'll look something like this. And since I've made them twice as many of them, and they're half as big, I need to multiply by my magic 1, known as 2/2. So that gives me the answer of 6/6, and each piece is going to be called 1/6. And similarly, if I want to change my 6 6 and I want to make them to have twice as many pieces, I multiply by my magic 1 again, and I get the following. I take my 6 6, I'm changing it into twice as many, or twice as small, or half as small, so I multiply by my magic 1 known as 2/2, and I get 12/12. Each of these are 12ths. So we can take a magic 1 known as 3 over 3 and change it into this, or I can change my magic 1 of 2 over 2 and get this. It doesn't matter which way I want to make. My magic 1 is always written as the same number on the top and the same number on the bottom, and that's going to change the sizes. So we've talked about making equivalent fractions, having the same value, the same length. All these rods are the same length. I've just renamed them into different names. 1 over 1, 2 over 2, 3 over 3, 6 over 6, 12 over 12, all by multiplying by a magic 1, which is going to allow me to take a look at and see things like 2 of these 6 is the same as 1/3. 1, 2, 3, 4 twelfths is the same as 2 sixths, which is the same as 1/3. They're all equivalent fractions, and in my next segment we'll talk about using those equivalent fractions to compare two fractions that have different numerators and different denominators, but are too close to tell, looking at the reference, or they don't have the same numerators and don't have the same denominators, so we can't use that technique. So we want to use the equivalent fraction technique and use the magic 1 in order to make that. We'll talk about that in the next segment.